Hi, I'm Adam.
And I'm David, and today we are doing our catalytic converter temperature lab. And we chose a 2018 Hyundai Tucson for the vehicle that we'll be using for this lab due to the fact that it has OBD2. Alright, here for the Hyundai, we're going to be getting our post-cat reading before we have the car started. It's going to be sitting at around 72 degrees room temp, and it should be the same for pre-cat as well due to the fact that we do not have the vehicle started. So right now I'm going to have Griffin start the vehicle, and I'm going to be taking the temperature every minute for the next 10 minutes of our temperature of our catalytic converter to see it heat up. Now I'm going to start taking the readings once Adam starts the car, and we will be getting pre and post cap for the next 10 minutes. Alright, here after a minute we can see that we're reading about 130 degrees pre-cat, and post-cat we're getting about near 100 right now. Here we're about the 5-minute mark, and as we can see we're getting readings about 260 degrees beforehand and about 150 degrees post-cat. So you can see that it has a crazy difference in temperature from before that catalytic converter to after. So now Adam's gonna rev it up to about 2,500 RPMs so that we can see the temperature of the cat increase. So after around 10 minutes of getting our readings, we have our pre-cat and post-cat readings, and our pre-cat was around 100 degrees hotter than our post-cat readings, and that was at idle. And then when we looked at around 2,500 RPMs, our temperatures increased to around 485 for the pre-cat, and then post-cat it was around 382. So there was still around 100 degrees difference in between the two. So that was good. And then we looked at the normal inlet temperature, and that was around 265 degrees Fahrenheit or so. Our outlet temperature at idle was around 170 degrees Fahrenheit. And then how long did it take to warm up? It warmed up in about 8 minutes and then started to settle out. The hottest exhaust spot was the exhaust manifold, and then our normal temperature drop from basically our catalytic converter to the muffler was around 450 degrees.
Hello.
Alright, so me and Adam are going to be doing the tailpipe emissions worksheet now, and we're going to be doing it on the 2011 Chevrolet Equinox. Alright, now we have started the vehicle, and we're looking at our heated O2 sensors for our first bank and second, and we can also see our short-term and long-term field trims. These are going to be our PIDs at idle, and as you can see we have a consistent streamline of data. So right here we're going to be looking at the PID values after Adam created a misfire, and as we can see it ended up getting very rich with our readings. And then we're going to go over a time lapse here over the PID values right after we created that value. So at first you can see it went very rich, and then as we tried to reinstate that condition, it tried to settle out, and all of our fuel trims went back to normal, as it should when the misfire is not created anymore because there's not excess fuel in the combustion chamber. So right now we're going to be looking at Adam causing a vacuum leak on the vehicle right now. And he's gonna pull the vacuum line right now. And as we can see, this is causing a lean conditions, and we can see displayed here by our PID values. So here one thing to say is that we noticed that these PID values were a lean condition due to the fact that those readings spiked, indicating that more fuel had to be dumped due to the engine indicating that it was lean and had too much air and not enough fuel. So it added excess fuel to make up for that lean condition. So now we're going to have Griffin injecting propane into the intake system. And when this happens, it should create a rich condition, and we should be able to see on our short-term fuel trims as well as looking at our O2 sensor readings. And what we're looking for when we're looking for these rich values is for these short-term fuel trims to go into the negatives as it's taking fuel away, and those O2 sensors reading a high voltage close to 1 volt, because that shows that we are reading rich, and that the PCM is basically telling your fuel injectors to take away fuel instead of adding more, because it knows that it's rich instead of lean. So when Griffin added the propane into the intake system, as we expected, the condition came out rich. So our O2 sensor voltage was high, as it should be for a rich condition, and it can see in our short-term fuel trims is that it was taking fuel away because it was determining that there was excess fuel because of the propane. So here we have our 5-gas analyzer, and as we can see, it measures hydrocarbons, oxygen, carbon monoxide, carbon dioxide, as well as oxides and nitrogen. It also gives us a lambda reading, and you can tell if your engine's running rich or lean by putting this in the exhaust tailpipe, and then it can give you these measurements. And these are some other readings taken off the 5-gas analyzer, which we used in class on Mr. Heisner's Impala.